Good morning, all the manufacturing colleagues, both from Germany and India. Thanks to VDMA for having me here. As I said, so manufacturing X, possibly I don't know, I may be at zero. But what I understood that we all working in a different sector, different aspects of manufacturing value chain. We all generate data, but the data which we generated in our company, maybe it is a useful information to somebody else, or the data would become kind of a concern for the others. The question is, can we collaborate? The major, to the extent I understood manufacturing X is basically is a cooperation and collaboration. So right, I think with that background, I was requested to speak on smart manufacturing. I have only one slide, smart manufacturing in India. Before that, yes, I try to emphasize how the data is important in the manufacturing. We know that manufacturing research happens, innovations happens in three basic domains. One is on the process technology. So a lot of data we generate with respect to processing. And then there is a significant progress with respect to machines and equipments where the value, the addition happens. That raw material is getting converted into a product. And the place where this all activities together, it is a system. That's where I think this manufacturing industry 4 or manufacturing X or digital manufacturing, whatever you call, these all have award. There's several technology award. All of us, no matter whether you are big company, small company, or you're a policy maker, everyone has an objective. But as a country, now we came out of the limit like made for India. So we started a journey of Make in India. To me, it is a process towards reaching made in India, if not originated in India. So if that is our objective, when we look at that, so yes, whether there is no choice now, but to use the data effectively and integrate the technology, whatever AML people are talking, to better utilize and better perform in terms of end of the day our turnover, right? No matter, see, investor will only look at that, no matter what technology you use, how beautiful product it is. The only is there are two things drives. One is cost of ownership of the product, and the second is investor wants the money back. So that is where the cooperation and collaboration matters. I think manufacturing X fundamentally lies on that principle, how to cooperate and collaborate to perform better than what we are today. In a manufacturing value chain, we generate a lot of data, right? I always call it no matter whether you make a water bottle is your product or your spacecraft your product. All of us deal with this 4P that I call it as product, process, people, and production. Or some people, you can also call it as a productivity if you want. So each stage, enough data is generated, and each disciplines emerged as several sub-disciplines, and whatever we do in engineering discipline, no matter whether you are a designer, whether you are a researcher, we need to look at addressing these challenges. So that is what the major focus, and we all do this, and this is a process. No, you can't bypass that. It is a process means there is a research stage, maybe conceptualize research, technology, then training and deployment, right? So every stage we create different set of data, and each data matters, right? Particularly we, at least I will always tell to my PhD student is, it is easy to do beautiful picture in the CAD, right? But making that, it is really tough. And a millimeter and a micron, so that at least 10 times tougher, right? So that is the kind of challenges we have. We need to do this, and we CMTI primarily focused on the last part, that is production. We are specialized in designing capital goods, machines, equipments, which are required to convert the product into convert the raw material into a product using set of process technology. And another is, irrespective of our engineering profession, whether it's computer engineer, electronics engineer, or mechanical engineer, we primarily focused on these 5 F's. Our objective is to engineering of a product and machine or a system. Maybe software engineer, software is the product, but for mechanical, maybe somebody make the machine or somebody design the product to use, which is meant for specific purpose. But what we normally does is these F's. That means we talk about form, function, flows. The year I might just to remember physics, but need not be physics, basically the science, physics, chemistry, biology, whatever the domain specific, and then the fabrication, right? We need to do this. That means there are 2 basic things at least youngsters should remember. Engineering will never be a 1 plus 1 is 2. It is always either 2 plus or 2 minus. And whatever the courses, 48 or 160, 170 credits we earn in engineering education, this is only to solve the problem. If it is 2 plus, bring back as close as 2, or if it is 2 minus, push towards 2. I think that is what we all engineers does, and using these tools. So we CMTI primarily try to focus on this. If you look at what we do is basically we do the research and develop machines and process technology, and we train the manpower to make them industry ready. So and then we deploy, unlike many of our sister R&D institutes, we primarily focus on applied research, so we ensure that this is deployed into the applications. And these are, like you can call it as a verticals. We focused on primarily on ultra precision machines, special purpose machines, sensors, controls, and then the aircraft, the test rigs, LRU qualification, those kind of things. Then precision metrology, smart manufacturing, micro manufacturing, and then the additive manufacturing. These are all the recent diversification happened in the institute. We established that CMTI was established just 500 meters from here in 1962 as a Central Machine Tool Institute. So from 90s onward, we are known as Central Manufacturing Technology Institute because our activities expanded. Just like snapshots, we are developing a technology, and we ensure that these technologies are licensed to, norms are assigned to the industry so that they can make multiples. If we given me an opportunity, I don't want to make second one which is similar to first one, because end of the day, whether I like it or not, I'm a scientist. My colleagues are scientists. So I think that is what the kind of focus what we do. So we have about now 75 technology, but last 65 years, CMTI built 500 machines that are new to India. I think that is what the kind of legacy. We built several machines. You look at these pictures, these machines, none of them are like prototype. They're all used in industry. And say for example, we always Indians, we take pride of Chandrayaan 3. This is the last machine. I think the former chairman of ISRO is there. We developed this machine which is used to prepare the solid propellant, and it is a 10-ton capacity machine. This is the largest machine ever built globally. And Chandrayaan carried about 220 tons of solid propellant that was prepared by the machine which is engineered at CMTI. So that's the kind of challenges we try to address and contribute to several government this. And this we call it as you can call Bhagavad Gita or Bible, whatever you want to call. This is our machine design and that book we authored. I'm sure thanks to all of you, still you are using this book as a CMTI Blue Book. Everybody knows this is a kind of a CMTI Blue Book. Now, if anybody is interested to digitize this, same that manufacturing X. So I think this is one opportunity. So we will discuss with you people because a lot of data we generate. This is with respect to design But beyond design, if you want to do, the technology enables us now, can we have the manufacturing advisory? Because nowadays lot of compromise happened on practice based learning in the engineering school. Everything is on PPT presentation, but notice the blackboard teaching is missing, right? That was more effective in our period at least. Now it is very difficult for an engineer to expect to contribute the day he joined. And at the same time, in Indian scenario, I don't know about Germany, but in Indian scenario, we had a concept of management trainee, which was usually offered by our CPSCs. Now that is missing. If I become a design engineer or somebody become a manufacturing engineer, is because of the 2 years training happened, rigorous training happened with this management training. I think that is grossly missing. Yeah. So then second is always this is like what you can say. Engineering of a product is a multidisciplinary approach. So you cannot expect to have an engineer have all the expertise. We need to collaborate. At least the mechanical engineer has to talk to electronics and computer engineer if you want to engineer the product today. I think that is what the kind of expertise what we have in one roof. So say for example, this is the largest machine which has a 1 meter cube built volume of additive manufacturing machine, and this is the first additive manufacturing machine, metal additive manufacturing machine, DAD machine, which is engineered with 100% domestic content. So that is the kind of that means you can easily appreciate what kinds of data you are generating even just to engineer one product. So that's possible when you talk to each other, talk to your neighbors, look at your neighbor as your enabler, not as a competitor. I think we strongly believe we work with all the ecosystem. At least 15 DRDO labs are our customer, and then all the ISRO labs we work. They'll range of like almost all the CFT institutes, central funded institutes are our collaborator in some way. So this is what I understood from smart manufacturing. We try to acquire the data. That means acquire the data from the real system, digitize and share to the stakeholder who does analytics and come up with the predictions. So in that process, the data is converting into information and then the knowledge to the wisdom of the company. I think this is a pyramid. It is well popular in smart manufacturing subject, right? So we are into that. We are developing a several technology. So I'm just skip that. What I try to do is here, smart manufacturing in India I captured in only this slide. The government, our Ministry of Heavy Industry supported the Summer Center initiative, where the 4 Summer Center and 1 more center, 5 centers, smart centers have been developed in the country. One at CMTA, another is IISc, the third one is at Pune, and fourth one is in IIT Delhi. The fifth one is IIT Kharagpur. All these centers objective was same, that is to acquire the technology, build a technology and disseminate the technology. That was the initial thought of 2016-17. But later these centers have been evolved as COEs. They have developed several technology, right? So now say for example, if you look at what is the advantage of AI and all, at least we realized yes, we can able to reduce at least to 20 to 30% kind of machine downtime, say for example, because we are metal cutting people. And then robotics and automation, these are all there in the public domain. And the leading ecosystem is now Bangalore is one of, you can consider as a industry 4 or smart manufacturing hub. At least say for example, just to mention, IASC as a smart factory and CMTA as a smart factory. So both are created with funding support from Ministry of Industry. And thanks to our colleagues, our partners, Siemens was our partner, and the Hexagon, Uttunga, that is Indian software company, HAL, BEL, Tata, and all they are our customer. So they used our services in CMTA. Similarly, Pune and Chennai is another 2 like metros kind of things. They evolved very well in terms of integration of smart manufacturing, both technology development as well as the deployment. Of course, there are several initiatives in the CPSC. This is one slide I try to capture what is the difference between like or how these are correlated, both Industry 4 and Manufacturing X. As Manohar and Rajesh mentioned, this is basically the extended version or avatar of smart manufacturing or Industry 4. The question is, this was Industry 4 more of factory centric. That means you can make a machine smart at the machine level, shop floor level, connect the shop floor to maybe you can take it up to MES level. But now we are looking at the complete ecosystem collaboration framework, how data generated by stakeholders could be utilized for the benefit of all. I think that is what is the trend. So that means possibly we were there. So that is what I already corrected. I try to put, but what we need to do is this. We need to build all the stakeholders, bring all the stakeholders on one platform. So for developing a technology or the solutions for everybody, that is what is there. I think I'll summarize here. It's possible, and yes, or it is useful if I am a small company or I'm a big company. It is all done, and who will own my data, who will protect my data. And second is, okay, every data is a junk data, right? So data need to be mined and utilized and all. There are several issues are there, but we need to change our mindset, so they definitely can be done. So I think I have gone through. This is relevant to India. A lot of development is required with respect to materials and machines and product and process innovations. Now the people are looking as these two big brothers, two brothers or two sisters. The one cannot go alone. And then the lot of requirement is there. We need to create a domestic IP. I think that is where the data makes a big difference. So, but at the end of the day, yes, cooperation and collaboration. If you really want to focus on advanced manufacturing systems and inclusiveness, so can we focus not for me, not it is for us. So that is, I think, mantra behind this manufacturing X. I think I will just end with this quote. So Einstein, right? So thank you very much for giving me an opportunity.